Hi everyone. I hope you guys are doing well. I wanted to take this time to walk you through this week's assignment on rational and irrational numbers. The first assignment should be submitted in Unified Classroom. The second assignment is an iReady lesson. As you could see, there are two additional links below that will help you with the concept of rational and irrational numbers. Let us take a look at the vocabulary terms. The first one says natural numbers. Natural numbers is the set of counting numbers. When you count, you usually start at 1. So 1, 2, 3, and so forth are your natural numbers. The next number is the whole number. This is a set of natural numbers and 0. And so whole number starts at 0, then it goes to 1, 2, 3, 4, and so forth. The third is the integers. Integers are your negative and positive whole numbers. So it's the whole number starting at 0 and its opposites. Now, this brings us to rational numbers. Rational number is a number that can be written as a ratio. When we say a ratio, we're talking about fractions. So rational numbers are fractions, and they're also repeating and terminating decimals. For example, any number that you could think of, if you can write it as a fraction, then it's considered a rational number. Even the number 5, this is considered a rational number because we can make this a fraction by putting a 1 under it. So rational numbers are fractions. As a decimal, it repeats. If it repeats with a repeating pattern. For instance, if I have a bar at the top of the 0.3, this tells me that the 3 repeats with that pattern 3, 3, 3, 3, 3. Or even an example as 0.125, that bar at the top tells me that it repeats 0.125, 125, 125. And as a terminating decimal, it just means it stops. So if I have something like 3.147, well, it stops here at 7. If I have something like 2.8, it stops at 8. So that is a rational number. A rational number can be written as a fraction. It can be written as a decimal that repeats, that has a repeating pattern, or it can be written as a decimal that terminates. This takes us to irrational numbers. Irrational numbers are the opposite of a rational number. Irrational numbers cannot be written as a fraction. It is a non-repeating, non-terminating decimal. So an example like pi, well, pi is a decimal that continues on forever and it does not have a repeating pattern. We use the approximation 3.14 to represent pi, but as it is written here, 3.14, this is a rational number because it stops here at 4, whereas pi, we know it continues on forever, and therefore pi is considered an irrational number. There are other irrational numbers, and I will take you to the perfect square chart that was introduced in week 8. If we look at these perfect squares, we see that these numbers here, like 1 and 4 and 9, when I take the square root of these numbers, it gives me a nice integer answer. For instance, the square root of 4 is 2 because 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 is 9. But what about the square root of 10? Well, I cannot think of a number when I multiply it by itself to give me 10, so square root of 10 is considered an irrational number. The square root of 170, I know that's a number that's going to be between 13 and 14, but it's not a nice integer number, so those numbers are considered an irrational number. All right, with that being said, good luck on this week's assignment.